Project 2.6.1 Mechanical. This project is an introduction of mechanical instruments to circuits such as motors, gears, and coils. For this specific project, a servo motor is used to display the Ames window optical illusion. Controlled by an Arduino Nano, the circuit takes inputs from a potentiometer and a switch to activate the servo motor and determine the direction that it rotates in. This system uses a continuous servo motor, which can rotate constantly without any boundaries. It connects to the power rail, the ground rail, and the PWM pin on a microcontroller to determine the direction and the rotation speed of the servo. The PWM signal is fed into the control circuit, or integrated H-bridge, which controls the rotation speed of the DC motor. The PWM signal ultimately determines the direction and duration of the output in the DC motor current, which uses magnetic poles in conjunction with the electrical signal coming from the circuit. These poles cause the gear shaft to rotate, producing a usable output on the servo motor. There is also a potentiometer with a knob in the gear shaft, which is used to balance and control current modulation from the H-bridge circuit. Coding the instructions for the servo motor on this project is fairly simple, since the Arduino only has to process 2 HID units. The program uses a 15,000 microsecond interrupt, which is used to send periodic instructions to the servo motor. It has another external interrupt, which is connected to the switch, which when turned low, sets the servo motor to 90 degrees where it is not rotating. At every interval, it takes in the reading from the potentiometer and maps the values on the analog scale from 0 to 1023 to 85 to 95. Standing position in the servo library is 90 degrees, meaning the servo does not move when it is set to 90 degrees. If a random input is less than 90 degrees to a minimum of 0, it rotates counterclockwise, where the difference between the number and 90 dictates the speed. The same thing applies for rotating clockwise to a maximum of 180. In this project, the servo motor is tasked with holding up the Ames window optical illusion, which requires a rotating base. It's fairly difficult for the servo motor to maintain its balance while supporting the optical illusion, so it uses a custom 3D printed stand. This is the Ames window. It appears as a 3D rectangle with holes cut into it to mimic windows and shadows along the insides of the window frames. It gives the impression that one end might be farther away than the other. However, this is just a result of it being a sideways trapezoid. When placed on a rotating platform, the geometric ambiguity becomes obvious when it appears to be oscillating, but we can tell that it's actually rotating from another source, the servo motor. The best viewpoint for seeing the optical illusion is along the horizontal axis, where the line of symmetry on the window is in the horizontal direction, and beyond the focal point, which is in a 2-meter radius around the servo motor. The focal point is defined by the position where all of the horizontal-ish lines intersect if they were to go on forever. This includes the edges of the window, the edges of the frames, and the inner edges of the horizontal axis. Being able to define a focal point in this direction ensures that the oscillation perception will appear. Thanks for watching.